All right, guys, here we go. We're going to start Unit 3, Objective 1, the end behavior. Okay, we're studying end behavior of functions. So let's get familiar with some vocabulary here, some new words that we're going to be using throughout this unit. So the first thing is the general form of a polynomial function is f of x equal a sub n times x to the n power plus a sub n minus 1 times x to the n minus 1 power plus, and then there's more terms in between, all the way until there's a sub 2 times x squared plus a sub 1 times x to the first power plus a sub 0. I know that this is very confusing and you're not familiar with this, you probably have never seen it, but this is just a general form. I know that you will recognize it if I write it as a number. For example, okay, if I write f of x equals, this a sub n is just telling us that there is a coefficient, okay? There's a leading coefficient because it comes first. So let's say it's a 7, and then there's x, and n is a power. So it can be any power. Let's say it's a power of 4, okay? So a sub n means it's a leading coefficient. Then there's the x, and then the n is a power, okay? And then plus, and then you have a second term. So this is your second term right here, and it can be anything. Let's pretend it's a 5 times x cubed. Notice that I'm dropping in power, okay? Originally here, the first one is a n, the second one is a n minus 1, meaning it's 1 less than n, so that's 4, and then 1 less than 4 is 3, and then it keeps going, dot, 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 all the way until we get to an x squared. Well, it should be next, right? X squared should be next because it's 4, 3, then 2. So let's pretend I have a 3x squared minus a, let's say, x plus a 2. So that's a polynomial right there. I know that if we show it in general terms with letters, with variables, you get confused, but this is all it's saying. It's saying the general form of a polynomial function is this form where the powers are non-negative integers. So look at the powers, 4, 3, 2, there's an invisible 1 here, and this guy right here is our constant. Okay, so that's all it's saying. This is the general form of a polynomial, okay? So n represents the power, and they have to be non-negative, okay? You cannot have negative powers here. Now, let's go ahead and understand a little bit more. The degree, okay? What is the degree of a polynomial? The degree of a polynomial is the highest exponent, okay, or power. So when I look over here, the highest exponent, or the higher power, is 4. So I say the degree of this function is a 4, degree 4, because that's the highest exponent, okay? So we are talking about the highest exponent of a function, okay? Now let's see the next word, the leading coefficient. The leading coefficient of a polynomial is the coefficient of the highest degree term. So it's the coefficient with the term that has the highest power. Well, this x has the highest power. So that tells me that the number 7 is the leading coefficient. Okay, so the leading coefficient, just to abbreviate lead coefficient, is a 7. Okay, sometimes the leading coefficient, sometimes the terms are all mixed around, and we have to kind of like rewrite them to put it in order so we can find the leading coefficient, okay? All right, so now we know what degree is, we know what leading coefficient is. Now the end behavior. So let me take this paper out, okay? So the end behavior. The end behavior of a polynomial describes the direction of f of x at the far ends of the graph, okay? So what we really want to study is the end behavior. Okay, so the end behavior is what is the graph doing on the far left and on the far right, okay, on the far ends of the graph. So we're going to be seeing two types of graphs. We're going to see odd graphs, okay, odd functions when they have an odd degree. So when they have an odd degree, like 3, 5, 1, 7, those are odd numbers, okay? If the function has an odd degree, then they go in opposite directions, okay? The left goes down, the left goes to negative infinity, okay? Here's left going to negative infinity, and the right, so this is the left of the graph, and the right of the graph is going to positive infinity. So that is a odd degree function, but this one, if it starts low and it ends high, that tells me I have a positive leading coefficient, okay? That tells me I have a positive leading coefficient if it has that shape, all right? Think about it, it has a positive leading coefficient, I'm going from lower to higher, I'm increasing, okay? Now, if it has an odd degree, but it has a negative leading coefficient, then on the left, we started high, we started at positive infinity, and on the right, it's going down to negative infinity. If the graph behaves like this, then that means I have a negative leading coefficient, okay? All right? So those are odd functions. Odd, they go in opposite directions. One tail goes to the left, one tail goes to negative infinity, the other tail goes to positive infinity. Now, if we have an even degree function, if our function starts with an even power, an even degree, then they're going to go in the same direction. The graph's going to go in the same direction. Think about x squared, okay? Just think about the function f of x equals x squared. That's a parent function we study in Unit 1. So if I was just to graph that, we're going to start at 0, 0. We're going to go up 1, run 1 to the right and to the left. And there is our parabola, right? We remember studying that. Well, guess what? That's an even power. That's an even degree, right? 2 is an even number. That's an even degree. So they both ends go in the same direction. The left and the right is going in the same direction, okay? Is going to positive infinity on both sides. So that's what they're saying over here. If you have the even degree, they go in the same direction. If it goes up on the left and on the right, on the left it goes to positive infinity, on the right goes to positive infinity, then that means we have a positive leading coefficient, just like a parabola, okay? If we have a positive leading coefficient, it opens up. If we have a negative leading coefficient, then it goes to negative infinity on the left, and it also goes on the right to negative infinity, okay? So that opens down, all right? So there's a difference between even degree functions and odd degree functions. So let's practice a little bit more, okay? I know it's overwhelming a little bit, but let's keep practicing. Let's take a look at number 1. It says, identify the leading coefficient, the degree, and the end behavior of the following functions, okay? So we have 3 things that we have to know is the leading coefficient, the degree, and the end behavior, all right? So when you take a look over here, you have y equals 3x to the 4th minus 2x cubed minus 7x squared minus 1. The first thing I check is to see that all powers exist. So for example, I start with 4, then I have to have a 3, a 2, it's missing a 1, and then it goes to a constant, okay? So it's the highest power is a 4, then drops to a 3, then a 2. It's missing the power of 1, but that's okay, and then it has a constant. All right, so what is the highest power? The highest number of exponent here, the highest exponent is a 4. So this guy right here is the highest term. The degree is 4. Okay, where did I get that 4 from? From here, the exponent. Okay, so remember, degree is exponent. I'm looking at the exponent, okay? All right, what is the leading coefficient? Well, the leading coefficient goes with the term that has the highest exponent. So the leading coefficient is 3. All right? Now, notice that the function has an even. So 4 is even. Okay? 4 is an even function. So we come back over here and we say we have an even degree and we have a positive leading coefficient. The leading coefficient is positive. Positive. Okay? So if I have a positive leading coefficient and is even, then we have this behavior right here. Okay? If I was to graph this function, we're not going to graph it, but if I was to graph this function, it would look like this. Okay? And right now we're just practicing recognizing the exponent, the degree of the function, we're recognizing the leading coefficient, and we're recognizing the shape, okay? So the end behavior on the left is going to go to positive infinity, and on the right, also going to go to positive infinity because our function is going to behave like this, okay? So that's all we're asking here. It's going to take practice for us to memorize even functions, odd functions, okay? But we're going to keep on studying here. All right, the second one, y equals 2x cubed, okay, or to the third power, minus 5x to the fifth, minus x squared. So remember, the degree, let's go back over here. On the top it says, the degree of a polynomial is the highest exponent, not whoever comes first, is the highest exponent. So when I look at number 2, the 3 is smaller than the 5, okay, the exponent 5. So this guy over here, I'm going to box it. This guy over here is the one with the highest power, this term, negative 5x to the fifth. So the degree of this function is 5. Okay, where did I get the 5 from? From the exponent of 5. Okay. What is the leading coefficient? The leading coefficient is the coefficient of the highest degree term. So it's this guy right here. So the leading coefficient is negative 5. So we have an odd function, okay, because the degree is odd, and we have a negative. So I'm looking for a negative odd. Let's go look at our box. Here's the negative leading coefficient, and that's the odd degree function. So it's going to behave like this. Okay, on the left, let's write it down. On the left is going to be high at positive infinity, and on the right is going to be down to negative infinity. It's going to start high, and it's going to wiggle down low like this, okay? All right? I would like for you to pause my video for a minute, and I want you to try to do number 3, and then you can unpause and then compare the answers with me. All right, so now let's go ahead and compare the answers if you pause me. All right, so y equals negative 2x to the fourth plus 6x to the sixth power minus 4. Okay, so find which term has the highest power. Right here, I'm going to box it because I'm looking at this guy. Okay, 6x to the sixth power. So what's the degree? The degree is this exponent right here. Okay, that's the 6. And that number 6, the number 6 is an even number. Now, what is the leading coefficient? Positive 6. So it's a positive 6. So I have an even positive. Again, here we go. I have an even function. There's only 2 kinds of evens, but this one has a positive leading coefficient, so it opens up. So on the left is going to positive infinity. On the right is also going to positive infinity. The shape is a open up like this. Okay, it has a wiggle in the middle. It's a little bit different than a parabola, okay, because it has a higher power. All right, so that's what we're practicing today, is recognizing what kind of function we have. Is it an odd or even function? Does it have a positive or a negative leading coefficient? And this little box right here is going to be in front of you. We're going to refer to it all the time, okay, so until we memorize it. All right, let's continue here on the notes. It says identify whether the function graph has an odd or even degree, and is it a positive or negative leading coefficient? Justify your answer, okay? So you should try to answer this without looking up here, but if you still need to look up here, it's fine, but you should start getting used to it, all right? So when I see going opposite sides, okay, one is going up to positive infinity on the left, on the right over here is going down to negative infinity. Because they're going opposite directions, then I know it's going to be an odd degree. That's all it's asking me. What kind? Okay, is it odd or even? So I know it's odd because it's going opposite directions. Is the leading coefficient positive or negative? Well, we started high, we started positive, and then you wiggled in the middle, and then you went down to negative infinity. So if you started high and end up low, it's because we have a negative leading coefficient. How do I justify my answer? It's very simple. I say on the left, our function was at positive infinity. And then on the right, our function went down to negative infinity, and therefore it is an odd negative leading coefficient function. Okay, that's how we justify is by the end behavior. Okay? All right, let's try number 5. By looking at it, they go together. They go the same direction. When they go in the same direction, that tells me it is a even function. So even. Okay, we don't need to know the number yet. We're just practicing recognizing odds and evens, positive or negative leading coefficient. On the left is going down to negative infinity. On the right is also going down to negative infinity. So the leading coefficient has to be negative because it's going down on both sides. Okay? How do I justify that? Just by saying that on the left is going to negative infinity and on the right is going to negative infinity. Okay? All right, here's a parabola. Okay? That's the example I was using first. We know that they both go in the same direction, going up to positive infinity and positive infinity on the left and on the right. So we know this is an even function. The leading coefficient has to be positive because it's both going up. How do I justify that? By saying on the left is going to positive infinity, on the right is also going to positive infinity. So you just have to memorize, based on the shape, odd functions and even functions, positives or negative leading coefficients, okay? All right, let's continue here. Let's keep practicing. I love this little box right here because those are the type of functions that we're going to be working with all the time. We have the even functions, and then down here we have the odd functions, okay? All right, so let's see what it says right here. It says, write a polynomial function with the following end behavior. We have to write a function that obeys these rules right here. On the left, the function f of x goes down to negative infinity. So I have something that goes down first. That's on the left. But on the right, it goes up to positive infinity. So I wiggle a little bit, and I end up going up to positive infinity on the right. Okay? So that's the drawing right here, just from reading this. On the left is going down to negative infinity, but on the right is going up. So what kind of function do we have? We have an odd function with a positive leading coefficient. Okay, we start at low, and then we end up high. So we can write f of x equals x2, as long as you give me an odd power, because it's an odd function, it works. So you can say x cubed, okay? And there's many possibilities here because you're just writing a function just to fulfill this requirement right here. So if someone said, oh, I want to write x to the 5th power, is that okay? Yes, it's okay. That's another example, okay? All right, so let's do it again. On the left, the function goes down to negative infinity. So let me start with the left, going down. But on the right, the function goes also to negative infinity. So on the right, it also goes down. So they go the same. Let's put a little wiggle in the middle. Okay, there we go. So that's the kind of function we have. So that means I have a negative leading coefficient. It's an even function right here with a negative leading coefficient. So let's write a function. F of x equals, I have to have a negative leading coefficient. So let's write negative 2. That's my leading coefficient. It has to have an x. And then let's go ahead and do a power, an even power. So let's go ahead and put a 4. Okay? As long as you give me a 4, it could be a 2, a 4, a 6, a 8, a 10. As long as you give me a even exponent. Okay? All right, so now let's practice some more. Sketch a graph of a polynomial function with the following requirements, okay? It has a positive leading coefficient and an even degree. So positive and even is asking me to sketch it. A positive even. Well, look it over here. Positive and even, I'm going to sketch this drawing right there. All right? Positive leading coefficient, even degree, it's right there. Okay. A negative leading coefficient with the odd degree. Well, a negative leading coefficient is right here. That's negative. But an odd degree, it would look like this. So we'll start high on positive infinity, and we wiggle, and then we end low, going down. All right? So there we go. We sketched that. It would be nice for you to practice this, recognizing them without looking at anything over here, okay? Practice understanding odds and evens, positive or negative leading coefficients, okay? All right, we're almost done. This is a short lesson. let's determine the degree of the polynomial in factored form. So this is factored. And then check by writing the polynomial in standard form. So they want us to check in factored form first, and then we will FOIL it, okay? We'll multiply it together and put it in standard form to double check our work, okay? I'm gonna need a extra piece of paper because I write big and I need lots of room here. So when you look at this and you have one factor right here, x minus 1 is one factor, and then you have x squared minus 2x plus 5 is another factor. So you have two factors, it's factored out, and you want to figure out the degree of the function. The standard form is when it's all together like this, okay? Problem number 1, that's in standard form. Number 2, that's in standard form. And number 3 is in standard form. Now they give it to us factored, okay? As a matter of fact, this is not fully factored, it's partially factored, but it is somewhat factored, okay? So how do I decide the degree of a function when something's factored? Well, what would you do? You would look at each of the exponents for each of the factor. So when I look at the very first factor, I have an x, okay, times, because this factor, the first factor is multiplying the second factor. And what is the highest degree of the second one here? Is x squared, okay? So if you multiply the x times the x squared, you'll get x cubed to the third power. Okay, I just took the x from the first, and I took the x squared from the second factor. And when I multiply them, I get x cubed. So I think the degree is 3. So the degree is 3. Now let's double check by writing the polynomial in standard form. Okay, so here we go. I'm going to actually FOIL this. I'm going to multiply it out. So I have an x minus 1 times x squared minus 2x plus 5. Okay? I'm going to multiply them slowly. X times x squared is x cubed. X times the negative 2x is negative 2x squared. And an x times a 5 is plus 5x. So I multiply the x times all those three terms. Now I'm going to do the negative 1. Negative 1 times x squared is negative x squared. Negative 1 times a negative 2x, that's a plus 2x, because negative times negative is positive. And then I have negative 1 times a positive 5, that's a negative 5. Now let's combine like terms, okay? Is there any other power of 3 here? Nope, so that's the first one, x cubed. I have a minus 2x squared and a minus 1x squared. So I can combine these two terms right here, and it gives us a negative 3x squared. We're just combining like terms. I have negative 2x squared minus 1x squared makes minus 3x squared. Okay? Then I have this 5x right here plus 2x, so that is a 7x. And the minus 5. So that is in standard form. Okay? This is in standard form. And now that it's in standard form, what is the highest degree? It's a 3. Okay? So that's the putting it all together in standard form. This is a standard form. Okay, that's a standard form. And the way that they originally gave it to us, it was factored. Okay, it's not fully factored, but it's partially factored there. Okay? All right, let's try one more time, letter B, and then we're done. So what we do is we look at all the powers in factored form. So I have an x to the 4th times, let's take our next factor. Our next factor is x plus 3 squared. That means I have 2 of them. It's like x plus 3 times x plus 3. So that means I have 2 of those x's, x and x. And then I have one more over here, is an x minus 4 times an x. So when you multiply them all, you have x to the 4th times x to the 1st times x to the 1st times x to the 1st. So that's 4, 5, 6, 7 is x to the 7th. Okay? So let me explain to you one more time how I got this. Let me slow down a little bit. I have the x to the 4th. Then I have the x plus 3 squared. And then I have the x minus 4. When something is a squared, it's telling me that there's 2 of them. Okay, so it's the same thing as saying x to the 4th times x plus 3 times x plus 3. That's the two of them, that's why it's a squared. And then you have your x minus 4. All right? So that's why I got the x to the fourth first. Then I have the x from this factor, the first factor. Then I took another x from the second factor. Then I took another x from the last factor. So 1, 2, 3, and then you have 4. And that's how I got the x to the 7th. Okay, that's the second time I'm showing you how I got it. So that's the factored form. They want us to put it together, all multiplied together. Okay, so let's multiply it nice and slowly, because they want us to double check this, our answer saying that the degree is 7. We're saying that the degree is 7. They want us to double check by putting in standard form. And it's going to be a little bit of work, but let's go ahead and do it. Okay? So I have an x to the fourth. Then I have an x plus 3 times an x plus 3, because it was a squared. Then I have an x minus 4. So let's go ahead and FOIL. Let's FOIL the middle term first. Let's FOIL this guys right here. Okay? Let's leave the x to the fourth alone. Let's FOIL x times x is x squared, and x times a positive 3 is plus 3x. And then let's do the 3 times x, that's plus 3x, and 3 times 3, which is 9. And then let's repeat our x minus 4 at the end. Okay? Let's combine like terms here in the middle. We still have our x to the fourth. Now we have times, okay, let's put in parentheses, x squared plus 6x plus 9 times the x minus 4. So all this work was just to multiply those two x plus 3's right there. Now let's go ahead and FOIL this x to the fourth. Multiply here, here, and here. So we have to FOIL 3 times, okay? So x to the fourth times x squared is x to the sixth. Okay, when we multiply the same base, we add the exponents. X to the fourth times 6x is 6x to the fifth. X to the fourth times a 9 is plus 9x to the fourth. So there we go. That's that right there, but we still have to multiply times the x minus 4. So we're going to go slowly. We're going to grab the x, and we're going to multiply times the first term, the second term, and the third term. Okay? So just the x's. X times x to the sixth is x to the seventh. X times 6x to the fifth is a 6x to the sixth. And x times a 9x to the fourth is a 9x to the fifth power. Now the last thing we got to do is multiply the negative 4. Okay, we're going to negative 4 times this one, negative 4 times this one, and negative 4 times this one. Okay? All right, so let's keep going. We're almost done. Negative 4 times x to the 6th is negative 4x to the 6th. Negative 4 times the 6x to the 5th is a negative 24x to the 5th. The last one, a negative 4 times a 9, a positive 9, it's a negative 36x to the 4th. All right? So we just multiply it slowly. And now we're going to combine like terms if there's any. There's no terms with 7, so x to the 7 is the first. Now I'm going to combine 6x to the 6th minus 4x to the 6th. Those two right there, which it gives us a plus 2x to the 6th. Now we have the 9x to the 5th and a negative 24x to the 5th. So we have to combine those two. It's going to be a negative 15x to the 5th. Okay? And then do we have anything else? Oh, we have the last one, minus a 36x to the 4th. So there we go. That is the standard form. Multiplying it very slowly. That's the standard form. And we were right. The power, the highest degree, is a seventh power, the exponent of 7, which is odd. Okay? So that is how you're going to be doing this. Good luck on your homework. See you later.